Hello, this is Luderijs from the Netherlands. This is the second tutorial to find the right information to make a new exploit. Now, what is an exploit? An exploit is that you can override a return address and execute your own code. In this tutorial, we can see there's two important values what we need. That's the length and the return pointer. With this information we can make our exploit and run our own code. At the beginning we're gonna start with finding some troubles in a server. Like okay, we're gonna send some information to the server and it's gonna respond normally. And at the beginning we have get the source and we're gonna disable ASLR. We must do this because memory randomization get us stuck. It's protection in the OS what we must prevent. Later on we're gonna compile our server and we're gonna run it. Now our server is running like normally. Now we're gonna send a message to the server, like sending 50 A's to the server. What you see that the server is getting the message and returning it back to us. It's working like normal. But when we send 250s, when we send 250 symbols, it doesn't respond anymore. Why is this? The main issue in this problem is that the vulnerability function is getting the issue. It's like it's overwritten the local buffer and it rewrites the return pointer. When it gets here, it gets stuck and it doesn't have the right return pointer anymore. Normally it's gonna go back to the main like he's ended, like over here. Normally he will do this function and he has a return pointer to this part, but it doesn't come that far because it's rewritten, because we sent 250 A's to it. Right now we're gonna discover how to find this pointer. Like okay, if we have done this function, where it has to be returned. Like okay, we cannot debug that. And when we are in debugger, we want to see what's the address of our return pointer. We're gonna disassemble the main code. What we are looking for is the vulnerability function. This vulnerability function has to be over here. You see, over here we need to do the vulnerability function. And where he must return to is this address. We can save this address to our variable list. These are the values we need to get. Later on, when we have found this address, we can look into the memory when we start this server. This server is using a fork function. A fork function it's a function that's that it has multiple processes. If someone sends a message, it makes a different process on. We want to debug that. I have saved that in the server. Info. Over here we see the option for GDB to debug fork functions. And when we copy this and we are debugging it, we cannot debug. At the moment we want to make a break in our fundability function, because then we know what he injected into the memory. Okay, we have the list. We're gonna list it at line 20. And when we see here, he's doing the fundability function, and we want to do a break on line 23. Like, okay, we do a break on 23. Now we're gonna start a server. And for every point, he's gonna break. But we don't need that. We just want to continue until he's breaking at line 23. Now we're gonna go back to the client. We're gonna send him just 200 A's. When we do that, it will respond normally because the buffer is 200 symbols. Right now, he's braked at line 23. And now we want to know if we can find a variable, this one, into the stack. First, we just watch the registry, and we're gonna look for the RSP, this one. We're gonna look into the memory, what values are in it. You see, we have sent a lot of A's, and it begins on this address. It's very important. We're gonna save this address over here. This is the GDB return point. This is the beginning of our buffer. If we look down, we can see over here that we have found our return pointer. Our return pointer, we want to rewrite that. At first, we need the length. What we already knew is the length of this is 200 bytes. What's next is, okay, how many bytes do we need to override this? Okay, we can count. 201, 202, 204, 200, 203, 204. Okay, this means 4. Then 8, 12, 16, 20, 24. It's like, okay, 224 charges we need to rewrite the return address. Like, okay, we saved over here. Now we can make a new code. Just exit the debug, kill the process, and in the background the main process haven't ended yet. We have to kill it. You can see here, this is the ID of our process. Kill. Now we're gonna debug again, and we're gonna make a code, just that we have all the information. We can use this information to make an exploit. We do the same thing, a break on 23. we do the child one. Child, and we're gonna start the server, and we just continue. We're waiting for a connection. Now we're gonna send 224. Like, okay, our return address is 8 bytes. What we have to do is 224 minus 8. That means 260. And now we're gonna add our return address. Like over here, we have 20 db ff 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 7f 0 0. And when we're gonna send this, it will rewrite our return address, and he's gonna jump to it, and he will execute that code. What kind of code will he execute? We will do 90. 90 is a process call that's doing nothing. It's a nub. And what he's gonna do is just do the nub function just all over the time. Now we're gonna send it to the server, and we're gonna debug the server. What you see, he's getting the information. Just show it over here. What he did is copied our string into the variable, and then he's gonna return. And when he's gonna return, he's gonna go to our return pointer, what we sent over here. He's gonna go to this memory address. What you see, he's going to that memory address. And what he's gonna do is nub. It's like our exploit is working. The only thing what we only have to do right now is make our own shellcode, fill it with nubs, put a return address to it, and then we made our own exploit. Now we see he's doing nub. The same thing we're gonna do all over again. But now we have to find a real memory address. What's the difference about GDB address and the real one? GDB can't find the real address. You have to do it differently. We use for this ulimit, C unlimited. This means when a program has a buffer overflow, we will make a report. We make a core file for us, and we can look that core file with GDB. I just showed. We run the server. It's still running. Just kill it. And we're gonna run it. Now we're gonna send again the same code to it. And it doesn't respond normally. It means it overrides the return address. When we stop the server, there's a core file. That core file we can open with GDB core. What you can see, there's something going wrong over here in this line. We can look to this line. What you can see, he's going to this line. And that's not the right line. The real address is over here, what you can see. My nubs begins in a real memory address in this address. It means the other address. It begins over here at 50. You can see over here better. It begins at this address. And now we have found a real address. The real address is over here. Now we know we found the real address, we can change the code over here, just like 50. When we run it again, of course, when we run it, it generated again a core function. It ended over here. just go a little bit up. What you can see, the line was this, 29. I could remember. That is this line. But you could see he has run all my nubs functions. And because he run all my nubs function, he ended over here. And this code is our return address, what we have injected before. It's like, okay, he run my nubs function. The only thing what we now have to do is make our own exploit, own shellcode at the beginning and just exit it. What I've made is two files, just to make it clear. This is a length file. Over here I put in how much length there is. We have collected 224. And over here I have input a return address. This is the return address. 50 dp ff 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 7f 000. It's like it makes it more easier to generate our own exploit code. Like over here, I've made a hex payload, just the shellcode. And in this shellcode is standing that it must display a message like hacked. That's all what the code does. And we want to use this shellcode. How we do this? Our shellcode is how many bytes long? Our shellcode is 45 bytes long. And what we knew our exploit must be 224 bytes. We have to extract the numbers of this. And we have the return pointer. Our return pointer is 8 bytes long. What we left with is how many? 171 bytes we left with. We have to fill that with nubs. What we've done before is over here we filled it with nubs. Now we do it with 171 nubs. Just like this. I do the nubs in the file. I put this in the file, nubs. What you can see, we have made a file with nubs, we made a file with a shellcode, and we have made a file for the return address. What we can do now is take the shellcode, print it out, put the nubs into it, and the return address. And together we make a new file, the POC file. And right now we have made our exploit. If we send this code, it's gonna inject it into the memory. The return pointer is rewritten and he's pointing to our shellcode and he will execute our shellcode. Now, just now for the real thing, we run it. And over here, we're gonna do a cat to the PEC file. X POC file. We're gonna send that to the server. What we now can see in the server, it's standing hacked. And it's working. This is how it's going. Hopefully I made it clear how you can find the right information and how you can use it. Later on I will explain how to make your own shellcode for injecting into a server. I hope it helped and good luck. Bye bye.